Welcome to this second part of the design and documentation of complex test system setups module. My name is Evangelos Rikos and I'm a researcher with the Center for Renewable Energy Sources and Saving. While the first part of this module showed you the fundamentals on how to use the methodology itself, this part is about presenting selected examples that facilitate the understanding of the use of this methodology. Before we proceed with the presentation of the examples themselves, it is useful to bear in mind the specific diagram that shows system configuration layers abstraction as they are connected to the different steps of the holistic test description methodology. In this respect, the examples we are presenting here are directly linked to these layers. The easiest way to explain the methodology itself is by using a simplified and easy to understand example based on a physical system that is governed by laws, physical laws that are understandable to the majority of users. In this respect, the selected example here is the light dimmer box that can be seen on the left-hand side diagram. The specific diagram, even though provides a lot of information to the user about the configuration of the system and how it pretty much works, it is still abstract in the sense that it doesn't describe in detail all the connections of the light dimmer box to the outside world. For example, we have electrical connections between the green and the light dimmer, or between the light dimmer and the light bulb, depicted as orange arrows, also showing the energy flows over time. And there are also interfaces illustrating interaction with the outside world, depicted as red arrows. The main scope of this test in this example is the investigation of three different functionalities. One is the tap function that is toggling between on and off at single tap. The second one is the long hold, that is the first to dim and then to brighten the light bulb. And the third one is memory, that is remembering the last level of dimming. Of course, these functions under investigation are connected to some other functions here listed as light dimming and light bulb emission, and under the category of functions under test. And these affect the behavior of the system. These functions under test are pretty much defined in the use case description. The next step is to identify the relevant information that is part of the test case description step in the methodology, starting first of all with the summary. The summary provides an overview of the system and how it works and the scope of the experiment of the test itself. And as such, it involves the narrative field, and it should describe the controllability of light level and the compatibility of light bulb. Once the summary is identified, then the next step, logical step in the methodology is the purpose of investigation. In this case, we have three different purposes for four different aspects of the system. We have to verify the light switching and the memory function. We have to characterize the dimming for different light bulbs, and we have to validate the haptic feasibility. Also, once we have the purpose of investigation specified, we can also identify the domains under investigation, that is the haptic and photometric ones. And having all this information, then we can move on to identify the test criteria that involve target metrics, variability attributes, and quality attributes. And with all this information, we have pretty much covered the first step of the holistic test description, that is the test case description. However, in order for the user to be able to move on to the next steps and analytically describe the test specification and experiment specification parts, an intermediate step is usually necessary. That step is the qualification strategy, which is useful because it helps in identifying the qualification results, insights, and possible experiments that are necessary. In this example, we have 3 different qualification results for 2 different experiments that are expected to provide 3 different insights. Based on this information, then, the user can specify the next steps, the next parts of the holistic test description template. And the most important ones here are the system setups. On the left-hand side, we can see the specific test system. That is a precise description of the minimum setup that is required for the specific test, and is included, of course, in the test specification template. From this exact representation of the test system, we can move on to the experiment setup, which is how to realize the specific test system in the laboratory. In this case, we define 2 different experiment setups. The left one here involves the use of an actual user, whereas the right one is fully automated. The main outcome of this analysis is that from a very precise test specification, the specific test system, we can choose then, depending on what is best for our experiments and for our test, the realization in the laboratory environment, and that could include actual physical components, physical emulation of parts, simulated parts perhaps, or even a pure simulation where everything is simulated in a software environment. Moving on to other more complicated examples, we have this example from AirGrid 2.0 that is about the operation of a microgrid, specifically the uninterruptible power supply of a microgrid. That is the seamless transition from grid connected to islanded mode without loss of power. In this respect, and because of the scope of this test, we have the system under test as the gray box illustrated here that involves all relevant components of the microgrid, and the related functions under investigation involve all the voltage and frequency control functions of the microgrid. There is, of course, another set of functions that affect the operation of the microgrid and should be considered in this test, like, for example, the battery management system, maximum power point tracking, etc. All these functions do nothing else than setting the scene for how the system would function under the specific conditions. After specifying all the relevant information in the test case part of the templates, then we move on to specify the specific test systems. In this case, we have 2 separate test specifications, only because there are 2 different objectives of this test. The first one, that is related to the frequency response, requires a specific test system that is rather simplified with the use of one aggregate load in place of the whole microgrid. While on the right-hand side of this slide, we can see a more complicated diagram for the specific test system, because in this case, we are investigating the voltage response in voltage disturbances, and in this case, voltage largely depends on a local phenomena like the power flows at local level. In this case, we need a more complicated specific test system in order to ensure the precise evaluation of our test case. Moving on to other examples. Here is another example from the FP7 EU-funded project Electra IRP. This test is about evaluating the performance of a set of novel control schemes that are used in the operation of future power systems. The system under test is, in this case, illustrated here in this gray box, and there is a list of objectives regarding the purpose of investigation specific to the this example. The functions under test here are also summarized and illustrated in the form of context UML diagrams or use case diagrams. From the high-level information in the previous slide, we can move on into realizing the experimental setup for this test. In this case, a setup that consists of 2 cells and a SCADA system and a high-level controller. Obviously, this setup provides more specific information as opposed to the previous diagrams, and involves a lot of technical details because it's related to the realization of the experiment itself. The experimental results of this test are summarized on the right-hand side diagrams here. Yet another interesting example comes from the EU-funded project Re-Empowered. This is also about a microgrid and the investigation of the interaction of grid forming and grid following inverters integrated into a specific microgrid located on Christmas Island. In this case, the system under test is a generic microgrid, and the function under test that are part of the analysis itself are the current control and the voltage control of the respective inverters. Here we also have some purpose of investigation related to the validation and characterization aspects of the microgrid functionalities and some test criteria. And based on those, a specific test system is selected. This system is nothing else than the actual diagram of the specific microgrid and the distribution of the sources and the consumers over it. And the experimental setup we can see on the right-hand side of the slide is a pure simulation realization in a MATLAB Simulink, in which we have the same microgrid setup realized in this Simulink model, including the specific inverters to investigate their interaction with the microgrid. Since the number of test cases is continuously increasing, one of the efforts that ERGRID 2.0 is attempting is to create a repository, a public repository, where all these test cases can be placed and accessed by anyone. In this respect, there is also work on harmonizing the methodology itself and the specific test cases that are used in the repository with the provision of specific tools for reporting. The link for this repository is provided here. However, this is an ongoing work, and as such, more results are due soon, so stay tuned for more detailed and final results about this repository. Thank you.